Okay, so linear regressions, that's the new unit. And so let's just review what we've been doing for the last couple of years, which is simply, let's open a new doc. And so control page, we're going to always add a calculator, but this time we're going to, control menu, we're going to add lists and spreadsheets. So what do? We basically start, for example, I gave you a bunch of X values, and we started off with the domains like 0, 1, 2, 3, 4, 5, 6. Okay, and then what we did was we created based on a formula. So let's make up a formula. How about a 2x plus 3? And so from that formula, we generated the y column, or the range values. Let's see. And so we then when we had all these points, these coordinates, we were able to plot them. So let's go to control doc. Let's add data and statistics. And let's add the x to the x variable, x-axis, and add the y to the y-axis. And then we noticed that these points made a nice line, and we went to menu. Let's see, plot properties, and we connected the data points. And we knew that this line had an equation of the equation had y equals 2x plus 3. And we did that with all different functions. So that's what we've been practicing. What happens when we, given a domain, we plug it into a function? We change it to, go back here and change it to, x, squared, right? Okay, and then we look at our new graph. The plots, let's take that out. And maybe let's go to menu, window, zoom the data, and we see we kind of have like a parabola. We could, I could add some other points, and I can go to, add, -1, -2, -3, -4. I can go back to once again, menu, zoom, fit the data. We have the parabola. Let me take this out. Whoops. It's okay. So we have a parabola, and what we've been studying the last couple of years is just what do these functions look like? Once again, given a domain, plug the numbers into the rule, come up with y values, plot the points. And so we study linear, exponentials. The question now is, we're going to flip this around. And what I'm going to do is, I'm going to take this out, and instead of, giving you an x and a y that depends on each other, or we don't know, I'm just going to give you a bunch of points, like a 3, 4, 5. Well, let's just keep the domain. Sorry. So 1, 2. But this time, I'm just going to put a bunch of points in here. 2, 4, 5.5, 7, 9, 10, 11, and let's take these out. And the question is, what we're interested in is what was the best equation that took us from x to y. Okay, and let's take a look at this picture. Let's go back to the diagram. Menu, zoom for the data. And so we're like, well, what? And that's the idea of regression. We're going to get two variables, an x and a y. They may not be related. They may be related. They may not be related. But we have an x and a y. We're going to plot them together, and we're going to see if we can connect them with an equation. Okay, and that's the idea of the linear regression. In this class, we're only going to look at two bivariate data, or a point that has two pieces of information, And that kind of looks like a line. Okay, and that's the introduction. Okay, so today we're just going to do the tech aspect of linear regressions. And the idea is, let me move my face out of the way. So the idea is, I gave you a document and I called it linear regression. And in this document, you will see these examples of bivariate data. And the idea is, maybe a person or a thing was asked a question, or we obtained data from it, but it was two pieces of information. So in this case, the first person, I wanted to know what their math test score was and how long it took them to run 500 meters. Now we call the first one X and the second one Y, but they might not be connected, like directly. You might say, Mr. Adler, what's the relationship? We don't know yet. But we were given these two pieces of information. We were asked to find a relationship. Another example is time spent talking on their phones, minutes, and the number of messages, M. Another bivariate data was, we asked individual people what their waist size was and what their BMI is. What else? Oh, we got a bunch of jigsaw puzzles. And we opened them up and we said, okay, how many edge pieces are there? And how many interior pieces are there? And this is the information we came up with. The last thing we asked was, we went to a database and we found all the men who said they were 165 centimeters tall. We found that on average they weighed 67.8 kilograms. It was same for 170, 175. Our goal as mathematicians are to, first, is there a relationship between this X and this Y? And then in a more advanced math class, we're going to determine if actually one causes the other. So, but let's just do the tech today. So we're going to enter the data. We're going to enter the data and get some data. We're going to start with this. A group of 7 adult men wanted to see if there was a relationship between their body mass and their waist size. Their waist size in centimeters was recorded and their BMI calculated. The following table shows the results. Okay, we're not going to answer these questions, the A and B, correlation, coefficient. We'll get to that. I just want to get this information into the computer. So let's see. Let me move this down. Let me hide this. Hold on a second. I don't need the letters. Perfect. Okay. Control. I'm sorry. Escape. So the first thing I want, new, and I'm going to add it. I always add a calculator, and I'm going to do Control Doc, and I'm going to add list and spreadsheet. List and spreadsheet to get that's my Excel spreadsheet. So we're going to label it the waist. Let's go to the top column. The waist is the first column. Well, IST. And the next column is BMI. Okay. And for each individual, let's enter both pieces of data. So for the first person, the waist is 58 centimeters. The BMI is 19. The second person is 63 and a BMI of 20. The third person is 75 and a BMI of 22. The fourth person is a BMI of 82. I'm sorry, a waist of 82 and a BMI of 23. The fifth person has a waist of 93 and a BMI of 25. And then let's see, the sixth person has a waist of 98, tab over to the right, and a BMI of 24. And the seventh person has a waist of 105. And a BMI of 26. Now you might see a relationship. You might say, well, you know what? As X increases, Y increases. And maybe it's, you say, oh, that sounds like a line. That's totally fine. In this class, we were going to be looking at something called a linear. The relationship is going to be linear. Well, I'll get to that in a second. The first thing you want to do is we want to find the mean of the waist column and the BMI column. Now, so let's see, menu, statistics, stat calculations, and you know what? I want two variables because let's just kill two birds with one stone. Sorry, I keep sitting on my feet and I'm a jittery person. So click two variable stats. The X list, let's see, the first, we're going to call the first list the X list, the waist. And the Y list is BMI. As I said before, we don't know if one directly affects the other. We just know that it seemed like there was a linear relationship. So we're going to call one X and the other one Y. There's no frequency list. We're going to put all this information in the C column. Okay, good. So let's go to the top of the C column, two variable statistics. Well, the X column or the waist column has a mean of 82. The sum of the data is 574. The sum of the squares is 48,000. So let's see. We saw that was necessary for the variance. This is the standard deviation of the X column or the waist is 16.4, and there's 7 pieces of data. Now let's look at the Y column. The mean for the Y column or the BMI is 22.7. The sum of the Y values is 159. The sum of the squares of those values is 3651. The population standard deviation is 2.37. And then these other things. Now, at the bottom here, this is the other piece of we're interested in is R value. We're going to see that in a second. So you're going to write the mean down for both columns and the R value. That's going to be important to us. Just on a side note, here's from the previous lesson. Here's the five number statistics of the X and the Y, and then so we don't need that. Okay. Now, once as I said before, this R value is going to be important. So let's go back. We have all this information. The next thing we want to do is we want to see the connection. So you're going to do Control, Doc, and we're going to add the data and statistics. Once again, this is just a visualization. And we see, okay, here's our points in there. They just threw them in there. On the X column, we're going to call that, what do we call it? As the waist. And in the Y column, we have the BMI. And so you say, oh, you know what? That kind of looks linear. It's not really the best linear, but we're going to get to that in another lesson. The question is there a line of estimate? I mean, in general, we just drew a line through all of them. We could do that. Menu, plot properties, connect data points. That's not really a line we're looking for. So let's undo that. Let's see if I can undo that quickly. Hide connecting lines. Yeah, I don't want that. But what we can do is we can kind of draw a line of best fit through that. And so we're going to do menu, analyze, regression, show the linear, and we can see that the line of best fit, which the calculator figures out for you, the equation is y equals 0.14 x plus 11.1, and this is a line. Actually, something of interest. Something of interest you can do is go back and find the mean, and put that as a 8th point. So let's say at the first it was 8. Let's see, it was 82. Let's put the means at the bottom. Let's see, 82, and what was the Y mean? Oh, you know what? Sorry, let's delete that. The 22.7. So let's see, right? So we had 82 and 22.7. 82 and 22.7. Nice. Now let's go back to our diagram. You'll notice, not coincidentally, that line of regression actually passes through the mean points. But once again, that's not we're not talking about the Y now. This is why we need the information. Now let's figure out this equation, but let's do it over here in this. So let's go over to. Let's go up to the top. Let's go over to the E column, and then let's go to menu, statistics, stat calculations. Sorry, I apologize. Cancel. Menu, statistics, stat calculations. The first choice was linear regression. That's where we're going to go. The X was the waist. The Y column was the BMI. We're going to save it to F1. There's really nothing at the bottom. Oh, no, F1 is the equation. And then the first column, we're going to stick it in the F column. So this actually will allow you in the calculator. Well, you know what? I'll do that in a second for you. Okay, and what we see here over in the FG column is actually we have our linear regression, mx plus b. But from the diagram, we saw the slope was 0.14. We have that here. The v was 11.5, and once again, we have that r of 0.977. The last thing is we actually created this function, and we can actually figure out values. So what I can do is, you might say, what you're going to be asked is, if this is the relationship between the data, for example, what about a guy who has a waist of 70 centimeters? Well, I can go to calculator 1, and I go to F1, open parentheses, put a 70 in there, and it gives, based on the equation, it predicts what the BMI will be, and so that's using the GDC to find all this information. Once again, enter the data in. You want to use two variable statistics, find the mean of both columns and the R. Then you want to make the picture, plot the points, the waist, the X and the X axis, and the BMI on the Y axis. Plot the points, then go to menu, regression. It puts the line in the equation, and then go back to the calculator and go with menu, statistics, linreg, put the X in the X, the Y in the Y, and then put it in the F, and then once again you have the data, and then once you know this F1 is the relationship that you created, you can go back to your calculator and figure out how to any value inside the value or outside the value. Good. Okay, so let's part 3. I put these together. So what's going on? We're going to talk about today. We're going to talk about correlation. And so let's talk about, first of all, bivariate data is simply it's data that comes in pairs. Data that comes in pairs, and so the idea is there's a person or a thing, and they're going to be like asked 2 questions, or we're going to get 2 pieces of information. For example, you saw in the on the sheet. We took a kid and we were like, what'd you get on the math test and how long did it take you to run the 500 meters? Or another example was we asked another person, what's your waist size and what's your BMI? Another thing we asked, so the idea is, we might take a city, what's the population and how much rainfall do you have? So the data may be independent or not. Once again, there may be a connection, there might not be. So the idea is you're going to plot the points, and to create a scatter plot. So as we saw in the previous video, I put a bunch of points in, like we always do. I put a bunch of points in the computer, and then we plotted those points, and we said it kind of looks linear. It looks like, but it was a plot. It was like a scatter plot, and so, or more importantly, it's a visual representation. A visual representation. Okay, so what we wanted, so we saw that obviously in this class, the scatter plot is like a picture is going to emerge. So from the picture, from the scatter plot, we want to determine if there is a correlation or a relationship between the 2 variables. Now, in this class, we're going to say, oh, it's linear. The idea is it looks like you can kind of draw a line through it. So in this class, it's linear, and as I said, it looks like we can draw. It looks like we could draw a line. Sorry. Through all the data points. All the points. And we might not get all of them, but like mostly through. The idea is, well, like what image arises. Once again, a correlation does not need to be linear. It could be exponential. It might be a parabola, quadratic. It could be a sine wave, like the weather or stock prices. In this class, you're going to be given bivariate data, and it's going to kind of look like you could draw a line through it. And let's know, in the last class I showed you the technology how to actually find the equation of that line. But today we just want to do a little more theory. So the idea is, what we're interested in is, before we do the technology, we want to talk about the direction and the strength. So the direction and the strength. And this is very straightforward. And just go something like this. The idea is you're plotting, let's say we have 3 scatter plots. And let's say here's our points. Over here, and then over here. Now, the question is, what's the relationship? So you would say, in each case, you would say, okay, well, as the x is increasing, the y seems to be increasing. So in all 3 cases, it's positive, positive, positive. But immediately you say, but Mr. Adler, they're not like all the same. It looks like this is really strong. This is moderate. And this is kind of weak. Once again, it all looks like they're increasing, like as x increases, y increases. But you're kind of like, nah, this is strong, this is really tight. This one's kind of moderate, it's kind of, and this one's weak. And then the same thing goes for, can you see the points? Yeah, and then the same thing goes for, let's do the same thing over here. You know where this is going. Let's do negative. So let's do plot, plot, plot. Can we see over there? Same thing here. Da 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 da. Da 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 da, and then. So once again, you look at the first thing we look at is the direction. And you say, okay, it's negative, like a negative slope, it's going down. It's just going down. So negative. Here is also negative. And also here is negative. But then you say, Mr. Adler, like the positive correlations, the strength is different. So in the first example I put up here, this one is strong. Yeah, I know it's decreasing as x increases, y decreases, but it's strong. Like I can really see a good line through this. What's going on here? Once again, this is moderate, and this is kind of weak. It's kind of weak, and so let's see. And then let me just get back. So what I kept saying is you can draw a line through. Well, in all 3 of these, the way you technically could draw a line, and we saw from the tech lesson, we can create this regression line. I can draw it through here. I can draw it through here, and I can draw it through here. And then for the negative, same idea. I could draw a line through here, and I say to you, so the idea is, well, these are the same lines of best fit. The question is, how do we differentiate among the line of best fit? And the idea is we're going to look for the R value. So the R value will help us determine which line strength is strong, moderate, or weak. Now, I'm not going to list it. You can go to on the online packet, and you can go to page 351, and you'll see on page 351, I'll put it right here. Take a snapshot. You can see at we found the R values. So at -1 or +1, this represents like strong positive, strong negative. And as you move closer to 0, the correlation gets weaker in the positive or the negative direction. So, for example, you might see this might be like R equals 0.98. But over here, this may be like R equals -0.97. And the numbers, and this might be R equals like 0.12. And over here, this is R equals -0.09. And that's the idea. You're not going to be asked to memorize these or anything like that, but that's the idea. It's either going to be blatantly strong or really weak, and you'll know it. Let's see, what else did I want to say for this lesson? Okay, so before you start reading the exercises, they're very straightforward. Let's just review what you're going to do. First, you're going to get a set of data, and you're going to enter in the GDC. Second, look at the scatter plot and make observations. Talk about the strength and the direction. I'm waiting for time. We're good. Next, you're going to use the GDC to get the regression and the R. Okay, and so you're looking for a strong R. If you have a strong R, we can do something called interpolate. So look for a strong R. Look for a strong R. Now, the next thing we want to do is we want to, find values that were not in the data table. Because if I have an equation, I can still plug in X values to get my Y values out. Once again, they might not be related, but I've created an equation that connects my X values to my Y values. The poles are the max and the min. And so if we want to interpolate, we want to look at X values between the poles and evaluate their corresponding Y value. Now you might say, okay, and if the R is strong, look for a strong R, you can interpolate. You also know the word extrapolate. Now, extrapolating means to look at an X value greater outside the poles. Now, you can use this, but make sure if they ask you to extrapolate, there's two issues. You have to believe only, so two issues. First of all, the data needs to continue the relationship. Outside the polls. And secondly, it's just unlikely to be reliable. And that's the issue. That's it. So we'll start doing problems, and let's say we're done. Okay, so let's answer a question. This one is on the sheet. A group of 7 adult men wanted to see if there's a relationship between their body mass index and their weight size. Their waist sizes in centimeters were recorded, and the BMI was calculated. The following table shows the results. So we want to find, they're saying that X and Y can be modeled by the regression equation Y equals AX plus B. Find A and B, find the correlation coefficient, and use the regression equation to estimate the BMI of an adult whose waist size was 95 centimeters. Okay, let's get to work. So first thing we're going to do is we're going to go to the calculator. Let me move my face out of the way. New. As I always have a calculator. And then we're going to do control, doc, add list and spreadsheets. First of all, I think I did this before actually, so let's do it again. You can waist. Let's see. So and BMI. So that was the A. The X. The BMI was the Y. Let's see. 58. 58 corresponds to 19. 58. Sorry. Let's see. 63.20. What's next? 75.22. What's next? 82.23. What's next? 93.25. What's next? 98.24. Last but not least, 105.26. Okay, the first thing I want to know is to find the regression. So let's do that. Menu, statistics, stat calculations. We want a linear regression. So it kind of looks like MX plus B. That's what they're asking. So number 3, the X list, we know that is waist. The Y list, we know that's BMI. We're going to save this regression equation as function F1, and we're going to stick it in column D. Okay, nice. Whoops, sorry. So let's see, the linear regression, MX plus C. So our first value is 0.14. So let's go back to the question. So let's see, A is 0.141. Is that 0.141? Yeah. And then the B, let's hide this. The B was 11.1. Nice. Next, so our equation is Y equals 0.141 X plus 11.1. Nice. Find the correlation coefficient. Okay, let's go back to the calculator. Our R, we're not looking at R squared, we're looking at R. It's 0.978. Let's see, R equals 0.978. And the last question, use the regression equation to estimate the BMI of an adult man whose waist size is 95. You have two ways. You could just plug it in here. You know that Y is equal to 0.141, open parentheses, 95, close parentheses, plus 11.1. And then you go to your calculator. Let's see, we go back to the calculator. So once again, let's see, what was the equation again? Because I keep forgetting, I get nervous. 14.1. Let's see. 0.141 times 95, close parentheses, plus, what was it again? 11.1. Enter. 24.5. Or remember, we saved the regression as function 1. F1, open parentheses, 95, close parentheses. Now, what's the difference here? I'm guessing that my rounding these off resulted in the error, which is not that much. You got 24.5 in both cases. Either way is fine as long as you show. I plug it in the original equation. Nice, and then that's basically it. So it's about 95 centimeter. No. Yeah, 24.5, BMI of 24.5. Let's see. So it would be, 24.5 BMI. And these are the basic things they might ask you. In another question, they ask you to switch it around. Let's see. Is that the correct? Yep. Nice. You can look at the answer key. Perfect. What else do they ask? Like in the jigsaw puzzle, they give it a tricky one here. You can figure that's a little bit of a challenge, but you can figure that out. In the question over here, they ask you to describe the correlation between the variables. And so in that case, you might go back to your graph. You might say, you know what? Let me add data statistics. This is waist. Well, let's see. Yes, waist, BMI. And you would say it's positive and it's strong. It's positive because as X increases, Y increases, and it's strong because the R is really close to 1. And that's basically it. I believe also I would like you to try all the problems in the book and all the problems. These are old IB problems. Try the problems in the book. Let's see if there's anything else. Just quickly going through it. Everything looks good. Yeah. That's basically it. And this H0, H1, the hypothesis, you're not being asked that. 5% significant level, you're not being asked that. And that's good. Excellent. Let's shut this off, and we're done.